That should be good. Let me ask you, anybody got any questions before we start? Questions, everybody's good. All right, let's start. Let me just erase this. 1 second. Okay. First, let's start with a little bit of a story. All right. So, two competing telephone companies offer different payment plans. The two plans charge the same rate per long distance minute, but a different monthly flat fee. A consumer wants to determine whether the two plans will ever cost the same amount for a given number of long distance minutes used. The total cost of each payment plan can be represented by a linear function. So to solve problems, we will need to compare the functions. In this section, we will consider methods of comparing functions using graphs. All right. And by functions, I mean like linear functions. So here we go. Let's talk about graphing linear functions. All right. So in linear functions, right, we saw that the graph of a linear function is a straight line. So we're starting off with just graphing straight lines. All right. We were also able to see that the points of the function, as well as the initial value from the graph, right? By graphing two functions, then we can more easily compare their characteristics. So there are three basic methods of graphing linear functions. The first is by plotting points. This is my number one go-to, plotting points, right? For the whole course, if you ever get confused about something, plot a point. That's the answer, right? Um, and then, of course, drawing the line and connecting the dots, yada, yada, right? The second way of graphing a linear function is by using the y-intercept and the slope. So you find the y-intercept, little rise over run, you found the second point, connect the dots, that's our line, boom, right? The third way is by using transformations of the identity f of x equals x or y equals x, right? So remember how we do our transformations? Like if we're adding a number, we're going to move up one, subtract number, go down one. You know, if we do x minus one, going to the right, x plus one, go to the left. Bless you, bless you. That's about it, right? And then of course, the whole shrinking, all that good stuff. All right. Let's talk about our first method real quick. It's the hotness right here. That's the good one. All right. So graphing a function by plotting points. To find points of a function, we can choose input values. Keyword there is we choose input values, right? Evaluate the function at these input values and calculate the output values, right? So blah, blah, blah. Pick a x, preferably 2, right? You could do 3 to be safe, but all you really need is 2, right? You plug it into the function, you get out a y value. Now you have a coordinate pair. You plot those two dots, little straight edge, connect the dots. You have a straight line. That's the end of it. All right. So the input values and corresponding output values form coordinate pairs. We then plot the coordinate pairs on a grid. In general, we should evaluate the function at a minimum of 2 inputs in order to find at least 2 points on the graph. For example, given a function f of x is equal to 2x, we might use the input values 1 and 2, right? Evaluating the function for an input value of 1 yields an output value of 2, which is represented by the point 1 comma 2. Evaluating a function for an input value of 2 yields an output value of 4, which is represented by the point 2 comma 4. Choose 3 points is often advisable, but if all 3 points do not fall on the same line, we know we made an error. All right. So that's like a safety check if you pick 3 points. All right. Before we jump into it, let me just give y'all a little bit of tea, a little bit of how to. All right. You don't want to be guessing over there, right? So given a linear function, we want to graph it by plotting points. Here's how you graph it, right? Step one, choose a minimum of 2 input values. 3 is safe, right? But 2 is all you need, right? Step two, evaluate the function at each input value. Step three, use the resulting output value to identify coordinate pairs. Step four, plot the coordinate pairs on the grid. Step five, draw a line through the points, and then that's it. All right. Good stuff, good stuff, good stuff. So let's try it out. So in this example, I want to graph f of x is equal to negative 2 over 3x plus 5 by plotting points, right? I could pick whatever I want to go in here, all right? Whatever I want. So watch what I'm gonna pick, right? I'm gonna make a little chart, x and y, right? I'm gonna just keep it simple, right? I'm gonna plug in 0 for x. When I plug in 0 for x, what do I get? What do I get as y? 5, exactly, right? Just so I'm clear, this is what I'm saying. F of 0 is equal to negative 2 over 3 times 0 plus 5, which becomes 0 plus 5, which is 5. Just so I'm clear, that's what I'm saying. All right? Okay. Now, right? I have to pick another point. What's an easy point that I could pick? One is pretty good. Let's go with that, right? So this is f of 1, which is equal to negative 2 over 3 times 1 plus 5, right? This becomes what? Negative 2 over 3 plus 5 over 1. Now, in order for me to put these two together, they got to have the same denominator, all that good stuff, right? So multiply this by 3. What do you do to the bottom? You do to the top. This is negative 2 plus 5 times 3, 15 over 3. Call that, what's that, like 13 over 3? So boom. So I have 1 and I have 13 over 3. Questions on this real quick before we keep going. All right, let's be safe. Let's do one more point. So give me another number I could plug in. Three. Three's kind of big. All right, let's plug in 3. All right. So f of 3 is equal to negative 2 over 3 times 3 plus 5. What does that become? Threes cancel out. This is negative 2 plus 5. Call that 3. Boom. Simple, right? So now I'm going to plot these points. Let's say I have a graph that looks like this. I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you're wondering why I chose 5 in this, one of my points has a 5 in it, so I figure why not? And then I'm looking at 13 over 3. What is 13 over 3? I don't even know. I got to go to the calculator for that. What is 13 divided by 3? What is that? 4.3? All right, we good. All I wanted to know is that it was smaller than 5. So I'm good. Right? So now, oh Lord, what happened? Oh, I think I know what happened. There we go. All right. So, go up. Okay. Now I want to plot these points. All right. So I have 0, 5. So I come across 0 and I'm gonna go across to 5, right? So 1, 2, 3, 4, 5. So I'm right here at the top, right? My next one is 1 and 13 over 3. So I go to 1, then I go to 13 over 3, which is like 4 and change. So that's like somewhere like right here, right? Last one is 3, 3. So I go across to 3, up to 3, boom. And then after that, get a straight edge or something. I recommend using your BCC ID, right? And then you just go straight across. Let me get a good color. I'm gonna do rainbow. Go straight across, right through the points. Boom, boom. And that's how you graph it using points. Any questions on this? We should also probably label this, right? I didn't even put a label on this, but this would be y equals, oh crap, negative 2 over 3x plus 5. Let me check one more time. Good. This is my x-axis. This is my y-axis. You know, you can even put like the points, the what they are. All right. So this would be like 0, 5. This would be 3, 3. This would be 1, comma. So x, yeah. 13 over 3. Questions on this? Anybody? We all feel like we know how to do this? All right.
I have a question.
Go ahead.
So, negative 2/3, the package is in the 2 or the 3 or both.
It doesn't matter. It's in one of them. It's either both of them, one or the top or the bottom. Yeah. Yeah. So but just know that it's not, it can't be in like the top and the bottom at the same time, because those will cancel out and make a positive. Yeah. So all right. I'm gonna keep talking, but y'all have enough information to do y'all homework if y'all want after this one example. Mhm.
Wait, you don't, oh, no, it's complete.
Yeah, it's there. Yeah.
Oh,
It's the last one that was posted last night. I owe you a homework though. I'm gonna do that later tonight. You'll get it.
ah,
And then I'll also send you guys a message about the test and all of that. All right. Special note. All right. So here's where the pretty graph is right here, so you can more clearly see, right? So we had the point 0.05, we had 3, 3, they chose 6, 1. Cool, whatever. You can choose whatever number you want, no pressure. All right. Connect the dots, draw a line straight through, and that's it. Questions on it?
You just have one. Okay.
You need 2 points at least, but you can choose as many points as you want. Yeah, yeah, yeah. No questions? We good? All right. They said we're good. A little side note. So the graph of the function is a line as expected for a linear function. In addition, the graph has a downward slant, which indicates a negative slope. This is also expected from the negative constant rate of change in the equation of the function. Okay. Would you guys like to try one, or you guys feel like you got the gist of it? Want to try one? All right. So this is the same game, right? We're going to plot the you're going to choose some x values, right? And then you're going to make your table, and then you're going to plot the points. Choose whatever you want to, no pressure, right? Whatever you want. I need a few more minutes. We good? All right. Excuse me. So I'm gonna make my table with X and Y. What X's did we choose?
Zero.
Zero, that's my favorite. All right. What's the Y value? Perfect. What else did we choose?
Four.
Four. Good, good. I like that one. What's my Y value? Three. Good. Give me another one. 12. 12 is good. I was thinking something smaller.
Four.
Now watch this one. -4. All right. Because if I choose -4, what does that become? Nine.
That's it. Nine.
Yeah. So you see what I'm doing? I'm choosing numbers that will get rid of the fraction, make my life easier. All right. So now let me get this graph going. All right. I need to go all the way up to 9. Just bear with me 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bear with me 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we get the idea. All right, and then x-intercept, y-intercept, do that. Okay, I have 0, 6, so I go to where 0 is, go up to 6. 1, 2, 3, 4, 5, 6. Then I have 4, 3. I go across the 3. 1, 2, 3, 4. Go up to 3. 1, 2, 3. And then I have -4. 1, 2, 3, 4. And then 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So like here. And then again, you use your straight edge. Go straight through the points. Boom. Right. And that's it. This is f of x equals -3/4 x plus 7, 6. All right. Questions, anybody? We good? Good. Now we're gonna learn a second method. So you want to graph a function using a y-intercept and a slope. All right. So another way to graph linear functions is by using specific characteristics of the function rather than plotting points. So the first characteristics of its y-intercept, right, which is the point at which the input value is 0, is to find the y-intercept that we can set x equal to 0 as the equation. The other characteristic of the linear function is its slope, m, which is a measure of its steepness. Recall that the slope is a rate of change of the function, right? The slope of a function is equal to the ratio of change in the output to the change in input. Another way to think of about the slope is by dividing the vertical difference or rise by the horizontal distance of run, right? So we encountered that both the y-intercept and the slope in linear functions, right? So we have f of x equal to 1/2 x plus 1. I'm going to consider that function. All right. So all right, so slope. The slope is, hold on. So it's too big. Okay. The slope is half, right? Because the slope is positive, we know that the graph will slant upwards from the left to the right. The y-intercept is the point on which the graph was x equals 0. The graph crosses, right, the y-axis at 0.1, right? Now we know the slope of, the slope and the y-intercept. We can begin graphing by plotting points 0, 1. We know that the slope is rise over run, which is m is equal to rise over run. So for example, we have m is equal to half, which means that the rise is 1, 1, and the run is 2, right? So starting from our y-intercept 0, 1, we can rise 1 and then run 2, or run 2 and then rise 1. We'll repeat this until you have a few points, and then we draw a line through the patient as shown. All right. So here you go. There's our graph. We have our y-intercepts, and we're gonna do rise over run to get the slope. And that's it. At that point, you just kind of empty it. Questions about this? Rise over run. Y-intercept. Let me just recap the whole, what's it called, rate of change thing. So graphical interpretation of a linear function. In the equation f of x is equal to mx plus b, b is the y-intercept of the graph and indicates the point 0, comma b at which the graph crosses the y-axis. M is the slope of the line and indicates the vertical displacement, right, rise, and horizontal displacement run between each successive pair of points. Recall that the formula for the slope is a change in input, excuse me, the change in output rise over the change in input, which is run, right? So change in y over change in x. And then, so questions on that? Right. So do all linear functions have y-intercepts? Yes. All linear functions cross the y-axis and therefore have y-intercepts. Note, a vertical line parallel to the y-axis does not have a y-intercept, right? And it's not a function, all right? We got a little bit of t. All right, so given the equation of a linear function, graph the function using the y-intercept and slope. So step one, you want to evaluate the function at the input value of 0 and find the y-intercept. Step two, identify the slope as a rate of change of the input value. value, sorry. Plot the point represented by the y-intercept. Use rise over run to determine at least two pistons on the, the line, right? So sketch the line that passes through the points. Questions on this? Anybody? Okay. All right. You guys try. Hmm. Well, maybe we did, but now we're gonna do it. We're using a y-intercept and a slope. So find your y-intercept, plot it, rise over run, done. That's it. All right, while y'all figuring that out, we got some water. Find the y-intercept, out the river. All right, let's take a look. What is my y-intercept here? Good. So your y-intercept is where x equals 0. Plug that in. We're gonna get back out 5, right? Boom. So I'm going up to 5. 1, 2, 3, 4, 5, right? So I'm right here, right? And then I want to do a little rise over run, right? So my slope which is equal to m, by the way, is negative 2 over 3, right? So I want to overrun that. So I'm going to rise negative 2. What does that mean? I'm going to go down negative 2, right? So this is going to be 1, 2. Then I'm going to run over 3, right? So 1, 2, 3. Right? So it's 1, 2, 3, right? Connect the dots. That's it. All right. So this is the point 0, comma 5. And then that point is, what's that? 3, comma 3, something like that. Questions on this? Anybody?
Um, um,
Do the opposite. That's fine. You can go backwards. I'll take that.
instead of, y, but instead of y.
X over Y. What do you mean?
And, like the negative two,
Yeah.
it's in control of the y-axis, three is in control of the x.
Got you.
Output the opposite.
Got you. Got you.
And now what it does.
Speaking of the negative though, right? You could have put that on the other side if you wanted. I mean, like the bottom. I called it negative 2 over positive 3. You could have said positive 2 over negative 3, and it's still been right. You just got to do the reverse, right? So if I'm rising positive 2, that means I'm going up, right? But you're gonna run negative 3. So if you run a negative 3, instead of going to the right, you're gonna go to the left. That's it. Okay. Well, depends on where you put your negative out, right? If you put it in the numerator like I did, then you're gonna go up, right? But or down technically. If you put it in the denominator, right, it just changes things, but you're gonna stay where you are. Yeah. Special note. So the graph slants downward, right, from left to right, which means we have a negative slope as expected. This next method, my least favorite one. So we want to graph a function using transformations, right? So another option for graphing is we use transformations of the identity function f of x equals x. A function may be transformed by a shift up, down, left, or right. A function may be transformed using a reflection, stress, stretch, or compression. So vertical stretch or compression. In the example, f of x equals mx, where m is acting as the vertical stretch or compression of the identity value, when m is negative, there is also a vertical reflection of the graph. So notice that in this figure coming up, that multiplying the multiplying the equation, right, of f of x equals x by m stretches the graph of f by a factor of m units if m is greater than 1. And compression, if the if wait, hold on, wait a minute. What did I just lost where I was? Compression of the identity function. When m is negative, there is also a vertical reflection on the graph. I'm going to notice it in the graph coming up that multiplying the equation by f of x equals x by m stretches the graph of f by a factor of m units if m is greater than 1 and compresses the graph of f by a factor of m units if 0 is less than m less than 1, a fraction, right, or a decimal, right? This means that the larger the absolute value of m, the steeper the slope, essentially, right? I hope this picture illustrates how much I really hate this method. All right. So all the colors represent different lines and they each have a slope with them, right? So for example, this brown one, f of x equals 3x, this is the slope here, right? So something to make note about. The larger the slope, the more steep the line is, right? Fractions are more like even lines, so to speak. You could have negative slopes that go the opposite way down. Positive slopes increase from left to right. Yeah, that's it. Questions on this?
But, right, it's like, we'll take a physical object, but
Yeah.
like, that's it, it's 3x,
Mhm.
now it's gx.
Mhm.
It's like, against this x.
Right. You can. Yeah. That's the thing.
But so as a keyboard.
Mm-hmm. Yeah, it's intense. All right, vertical shift. All right, if f of x is equal to mx plus b, the b acts as the vertical shift, moving the graph up and down without affecting the shape of the line. Notice that in this next figure, by adding the value of b to the equation f of x equals x, shifts the graph f a total of b units up if b is positive and absolute value of b units down if b is negative. All right. Questions on this? Just shifting it up and down, that's all. All right. So using vertical stretches or compression along with vertical shifts is another way to look at identifying different types of linear functions. Although it may not be the easiest way to graph this type of function, it is still important to practice each method. Okay? Right. Let's see. So given the equation of a linear function, use transformations to graph the linear function in the form f of x equals mx plus b. We're going to graph f of x equals x, and then we're going to vertically stretch, compress the graph by a factor of m, and shift the graph up or down b units. All right. Here you go. You guys try. So graph y equals x first, and then we're going to multiply it by the slope that we're given, and then you're going to shift it either up or down. That's it. So it's probably the most basic line ever, right? So this is the original equation. This is y equals x, right? I'm going to shift it down 3 units and then match whatever the match the original. It's just parallel. This would be y equals 1/2 x minus 3. Right? Questions on that? Not a computer, so I'm kind of just approximating what the slope would be like.
Well, look at this one mistake.
It can tell you that the slope is positive.
Yeah,
It tells you like what it looks like. I hate this method.
yeah, you know, it's.
Yeah,
I would take the Y to the two, but
yeah,
I changed the Y, but I take that.
yeah. That's the first one though. When you plug in points and stuff, you can do that. Like the other one is more precise, the other methods, so I like those better, particularly the first method. This one, not so much, but I understand if you need to use it or you want to use it. That's it. All right, let's take a look. Hypothetically speaking, I have a graph like this. Right through the origin, this is y equals x. Now this is up 4 units. So 1, 2, 3, 4. Right? And then we want to look at and then my slope is a little bit more steeper. So maybe something like this. All right. And that's it. Oh, let me label it. All right. Questions on this? It's plotting points. Okay. All right. So could we have sketched a graph by reversing the order of the transformation? No. The order of transformation follows the order of operations. When the function is evaluated at the given point, the corresponding output is calculated following the origin of operation. This is why we perform the comparison test. For example, follow the order. Let the input be 2, right? So f of 2 is equal to 1/2 2 minus 3, 1 minus 3, and then -2.
And, uh, what we place in the same graph. Like I said,
Yeah, that wouldn't be the same. And finding the x-intercept of a line. So far, we have been finding the y-intercepts of a function, the point at which the graph of the function crosses the y-axis. A function may also have an x-intercept where the x-coordinate is the point where the graph of the function crosses the x-axis. In other words, it is important. It is the input value when the output value is 0. Said a little differently, I'm going to give you a function, set the equation equal to 0, solve for x. That's it. All right. So to find the x-intercept, set the function f of x equal to 0, solve for the value of x. So for example, f of x equals 3x minus 6, right? We're going to set that whole function equal to 0, add 6 to both sides, divide by 3, boom, boom, boom. We have x equals 2. So my x-intercept, right, is 2 comma 0. Questions on that? After that, we back to the same old thing. Plot the point, connect the dots, all that good stuff.
this is not the points.
Right. It'll always work for you finding the points. Always, always, always. So do all linear functions have x-intercepts? No. However, linear functions of the form y equals c, where c is a non-zero real number, are the only examples of linear functions, right? Where no in with no x-intercept. For example, y equals 5 is a horizontal line, right? 5 units above the x-axis. The function has no intercept, all right? No x-intercept. So you can see y equals 5 is there, doesn't touch the ground. The x-intercept of a function is the value of x when f of x equals 0, could be solved by the equation 0 is equal to mx plus b. In case we didn't figure that. So this question is asking us to find an x-intercept, right? So we know the x-intercept is where y equals 0, right? So I'm going to set this equation equal to 0. So f of x is going to be equal to 0. So 0 is equal to 1 half x minus 3. Solve for x. That's it. Add 3. Add 3. All right. Divide by half. Divide by half. So b is equal to 6, right? And then that would be my intercept. X-intercept, this would be 6 comma 0. Questions on this? Okay. You guys want to try? Hmm? Oh, it's the same one? My fault, my fault. I want to make a special note real quick. So 6-0. This is how it looks. Boom. Yada yada. Here, you guys could try this one. Reminder, set the equation equal to 0. Solve for x. That's simple. Good? So I'm going to set this equation equal to 0. So 0 is equal to 1/4 x minus 4. I'm going to solve for x. I'm going to add 4 here. So I have 4 is equal to 1/4 x. Divide by 1/4. Right? So I have x is equal to, what's this? 4 times 4, 16. So this is 16 comma 0. Oh, I'm sorry. Because this is like 4/1 divided by 1/4, right? So keep change flip. This becomes 4/1 times 4/1. Right? Keep the top, change the bottom, straight across 16/1. That's how. Questions on this? You can totally use a calculator. You ain't gotta memorize that.
Yeah,
Yeah.
that.
Yeah, yeah.
I did 1/4 times 4.
Times 4, not divided. Yeah, yeah. So we're describing horizontal and vertical lines here. So there are two special cases of lines on the graph, horizontal and vertical. A horizontal line indicates a constant output or Y value, right? As you can see in the figure. We see that the output has a value of 2 for every input value. The change in output between any 2 points therefore is 0. In the slope formula, the numerator is 0 and so the slope is 0. If we use m equals 0 for the equation f of x equals mx plus b, the equation simplifies f of x equals b. In other words, the value of the function is constant, right? So this graph represents f of x equals 2. Okay. Special note, a horizontal line passes through the function f of x equals 2. Will be this, where all my y values are 2. My x values, they change from destination to destination on the line. Okay, so the vertical line indicates a constant input or x value. We can see that the input value for every point on the line is 2, but the output value varies. Because the input value is mapped to more than one output value, a vertical line does not represent a function. Right, so notice that between any 2 points, the change in the output in the input values is 0. In the slope formula, the denominator will be 0, so the slope of the vertical line is undefined. Right? So slope is equal to change of output over change of input. The output came from a non-zero real number. And you get the idea. So lines can be horizontal or vertical. A horizontal line is a line defined by the equation f of x equals b. A vertical line is defined by the equation x is equal to a. Okay? Simple stuff. One second. So next we want to write an equation for a horizontal line. What's this equation? So it's horizontal, right? Say it again. Good. Question, anybody? How about this? How about that? Questions, anybody? Good. Okay. All right, let's take it up a notch. So we're going to be determining whether lines are parallel or perpendicular. It's real simple. We just got to look at the slope to tell this, right? So two lines, like in this image down here, are parallel if they will never intersect. Notice that they have exactly the same steepness, which means that their slopes are identical. The only difference between two lines, right, is the y-intercept, right? So if we should shift one vertical line towards the y-axis in the other, in the y-axis of the other, they would become the same line, right? So parallel numbers, they move like a diagonal, no? No pressure.
So I start with only be parallel, we only change the B, y is an plus B.
Not necessarily.
Like y equals two x plus five versus y equals two x plus seven. They would become, but if they had changed that x equals seven,
Mhm.
it would be different. So we got like y
Mhm.
on vx plus two and y four x plus two. They would touch.
Ooh, sorry. Got you, got you, got you. All right. So we can determine from their equations whether two lines are parallel by computing their slopes. If the slopes are not the same and the y-intercept are different, then the lines are parallel, right? If the slopes are different and the lines are not parallel, right? So for example, we have negative 2x plus 4, negative 2x minus 4. It's parallel. We have non-parallel when we have XO 32 plus 2. Wait, yeah. We have for not parallel, we have f of x equal to 3x plus 2, f of x equal to 2x plus 2. So parallel, same slope, different y-intercept. That's all you need to know. So unlike parallel lines, perpendicular lines do intersect. They intersect to form a right or 90-degree angle. The two lines in Europe are perpendicular. Okay. So perpendicular lines do not have the same slope. The slopes of perpendicular lines are different from one another in a specific way, excuse me. The slope of one line is the negative reciprocal of the slope of the other line. Remember that. Hold on. Excuse me. The product of a number and its reciprocal is 1. If M1 and M2 are negative reciprocals of one another, they can be multiplied together to yield -1. So to find the reciprocal of a number, divide 1 by the number. So the reciprocal of 8 is 1 over 8, right? And the reciprocal of 1 over 8 is 8. To find negative reciprocals, first find the reciprocal and then change the sign, right? So as with parallel lines, we can determine whether two lines are perpendicular by computing their slopes, assuming that the lines are never horizontal or vertical. The slope of each line below is a negative reciprocal of the other one. So the lines are perpendicular. So we have f of x equal to 1 over 4x plus 2. Negative reciprocal would be -4. I have f of x equals -4 plus x. Negative reciprocal would be -4. Hmm? -4x plus 3. Negative reciprocal of -4 is 1 over 4. Okay, so the product is the slope of -1. As you can see, -4 times 1 over 4 is equal to -1. All right. So parallel and perpendicular lines. Two lines are parallel if they do not intersect. The slopes of the lines are the same. F x equals to m1 times x. B2 is equal to, excuse me, G1, Gx is equal to m2x plus b squared are parallel if m1 is equal to m2, if and only if b1, if only if v1 is equal to b2 and m1 is equal to m2, we say, right, the lines coincide consistent levels at the same line. So two lines are perpendicular lines if they intersect at a right angle. So f of x is equal to 1 m1x plus b1, and g of x is equal to m2, what you call it, m2x plus b2 are perpendicular. So if we take the two slopes, m1 and m2, multiply together, we'll get -1 and so on. M2 is equal to negative of 1 over m1. Yeah.
It's square.
Yeah. Mm-hmm. They have it. So identifying parallel and perpendicular lines. Given the functions below, identify the function whose graph are a pair of parallel lines and the pair of perpendicular lines. So definitely F and J. That should be our like terms, perpendicular. So so I noticed that F and J have the same slope. Those are parallel. These two, H and G, right? Notice that they have negative reciprocal slopes, right? So these two, the G of X and H of X are perpendicular. That's it. So writing the equation for a line, parallel or perpendicular to a given line. So if we know the equation of a line, we can use what we know about the slope to write the equation of a line that is either parallel or perpendicular to the given line. So writing equations of parallel lines, suppose, for example, we were given the following equation, f of x equals 3x plus 1. We know that the slope of the line formed by the function is 3. We also know that the y-intercept is 0, 1. So any other line with a hope of 3 will be on the panel f of x so that the lines form all the following functions that will be parallel. All right. Suppose then we want to write the equation of a line that is parallel to f and passes through the point 1 comma 7. We already know that the slope is 3. We just need to determine what value of b will be correct, value of b will give the correct line. We can begin with the point slope formula of an equation of a line and then write in the slope intercept forms, right? So y minus y1 equals m times x minus x1. Believe this is on your formula sheet, so you even got to memorize it, right? Y minus 7 equals 3 times x minus 1, right? Then we simplify it down to y equals 3x plus 4. So if g of x is equal to 3x plus 4 is parallel to f of x equals 3x plus 1 and passes through the point 1 comma 7. Let me give you all a little how-to. So given the equation of a function and a point through which its graph passes, write the equation of the parallel line to the given line that passes through the good point. So first you want to find the slope of the function. Two, you want to substitute the given values into either the general port slope authority or the slope intercept education for a line. Simple. For a line, simply. Simplify. So finding a line parallel to a given line, right? So find a line parallel to the graph of f of x is equal to 3x plus 6 and passes through the point 3 comma 0. So if this is parallel, what's my slope? If this line is parallel, the line I'm about to make is parallel, what's my slope going to be? Using this equation. 3. Thank you. All right, 3. And I want to pass through the point 3 comma 0. Real simple. Equation of a line. Y equals mx plus b. I know my slope. Y is equal to 3v plus x. What am I talking about? 3x plus b. I need to solve for b. I don't know what b is, right? I have an x and a y here. Plug them in. So now I have 0 is equal to 3 times 3 plus b, right? 0 is equal to 9 plus b. And then we want to subtract 9. Right? So subtract 9. B is equal to -9. All right. We write the equation. This becomes y equals 3x minus 9. And that's it. Questions on this? Good. All right. Got it? All right.
Maybe I'm trying to figure out what the, transformation that needs to take place where it's a touchdown point.
Exactly. Has to go through that point and be perpendicular with the other line that's there. There we go. So we can confirm that two lines are parallel by by graphing them. There they go. This shows that the two lines will never intersect. That's parallel. Questions on parallel? If the slope is the same, you can tell by looking. Yeah. Yeah. Perpendicular, let's talk about it. Okay. So we want to write equations of perpendicular functions now. All right. So we can use a very similar process to write the equation of a line perpendicular to a given line. Instead of using the same slope, however, we use the negative reciprocal of the given slope. Suppose we're given the following function, f of x is equal to 2x plus 4. The slope of the line is 2, and its negative reciprocal is negative 1 over 2. Any function with a slope of negative 1 over 2 will be perpendicular to f of x, right? So with the lines formed all over the following functions will be perpendicular, right? For f of x. So we have g of x equals to negative 1 half x plus 4. H of x equals negative 1 half x plus 2. P of x equals negative 1 half x minus 1 over 2. They all have the negative reciprocal slope of the original function. So all of these are different lines and all of them are parallel to the original right here. Right?
We all
Uh-huh.
that, X positive to be perfect.
It doesn't matter the x, the slope is what matters, right? It has to be different. Negative reciprocal slope. So as before, we can narrow down our choices for a particular perpendicular line if we know that it passes through a given point. Suppose then we want to write the equation of a line that is perpendicular to f of x and passes through the point 4 comma 0. Now we're back to what we were doing before. We already know that the slope is negative 1 over 2. Now we can use the point to find the y-intercept by substituting the given values into the slope intercept form of the line and involving for b. So g of x equals mx plus b, plug in the negative reciprocal, plug in the x and the y value, solve for the b, which is the y-intercept. Boom, 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 we got b is equal to 2. Cool. The equation of the function with the slope of negative 1 over 2 and a y-intercept of 2 will be g of x is equal to negative 1 half x plus 2. So g of x is equal to negative 1 half x plus 2 is perpendicular to f of x's 2x plus 4 and passes through the point 4 comma 0. Be aware that perpendicular lines may not look obviously perpendicular on a graphing calculator unless there's a zoom a square zoom feature. Square zoom. Okay. So a horizontal line, right, that has a slope of 0 and a vertical line that has an undefined slope. These two lines are perpendicular, but the product of their slopes is not. So doesn't it, doesn't this fact contradict the definition of perpendicular lines? No. For two perpendicular linear functions, the product of the slopes is -1. However, a vertical line is not a function, so the definition is not contradicted. All right. Keyword there, vertical line is not a function. So given the equation of a function and a point through which its graph passes, write the equation of the line perpendicular to the given line. So find the slope of the function, determine the negative reciprocal of the slope, and then substitute the new slope and the value of x and y from the coordinate pair provided into g of x is equal to mx plus 7, right? Solve for b, write the equation of the line. Okay. Okay. What about the answer to this one? It says find the equation of the line perpendicular to f of x is equal to 3x plus 3 that passes through the point 3 comma 0. Find the negative reciprocal, plug in that value, get your b, rewrite the equation of the line, we'll call it a day. Give you all a minute to do that. Get the canteen. Where'd you get the canteen?
Oh, there's a job little fair thingy.
Lucky.
It's pretty good.
Yeah, that's official, man.
I thought it would be trash because I hated that when I was like, I'm probably gonna feel right through the cup.
Yeah.
But it was like,
Yeah, so it holds hot and cold, right?
yeah.
Yeah. How we feel? We good? So first thing I want my perpendicular slope. So M perpendicular. This is going to be what? Negative what? 1/3, right? And then now I have my point, which is 3 comma 0. And you already know y equals mx plus b, right? Just plug it in, right? So the y was 0, the m is -1/3, the x is 3 plus b. This becomes what? 0 is equal to -1 plus b. Then we want to add 1 to both sides. Okay. So now let's rewrite what we have. This is going to be y equals -1/3 x plus 1. So this is our perpendicular line that passes through the point 3 comma 0. Excuse me. Questions on it? Same process. Mhm. Some of you might want to actually see it. This is how it looks.
You know, I mean, let's vote.
And made it negative. All
There
right.
you go.
Yeah. You guys get it, or you want to try another one? Another one?
So it was already negative, but, right?
Exactly. Yeah. So I'm giving you an original function. I'll give you a point that it goes through. I want two things. I want a parallel line and I want a perpendicular line here. All right. So let's look at A. For A, I want a parallel line, right? So in a parallel line, what's my slope? Well, the 2, right? And then the point I'm going through is 0, 0, right? So y equals mx plus b. Plug this in. 0 is equal to 2 times 0 plus b. All right. So b is equal to 0. So what's my equation? Y is equal to 2x plus 0, but you get the idea, right? Yeah. Now, I want the perpendicular one. What's my slope for the perpendicular line? Perfect, negative 1/2. And then my point is the same point, 0, 0. Right? Now I'm going to plug it in. So I have y is equal to negative 1/2 x plus b. Plug in the point, 0 is equal to negative 1/2 times 0 plus b. Right? So 0 equals b. Let's rewrite what we have. Y is equal to negative 1/2 x plus 0, but you get the idea. And that's it. Questions on this? Parallel and perpendicular. Good? Feel like parallel and perpendicular is like most of your homework. Okay, so little how to. So given 2 points on a line and a third point, write an equation of the perpendicular line that passes through the point. Here's how you do it. Step 1, determine the slope of the line through the passing point. Step 2, find the negative reciprocal of the slope. Step 3, use a slope-intercept form or the point slope formula to write the equation by substituting the unknown value. Step 4, simplify. That's it. So finding the equation of a line perpendicular to a given line passing through a point. So a line passes through the points -2, 6, and 4 and 5. It says find the equation of a perpendicular line that passes through the point 4, 5. All right, give y'all a minute. Very simply, find the slope. I want it to be perpendicular, so you already know. Negative reciprocal. It don't matter which point you wait. Hold on. Perpendicular. Yeah, they gave you the point that it moves through. 4, 5. Plug it in, get the B, and then that's it. Okay. So first thing we want to do, let's find this general slope that we have. M is equal to y2 minus y1 over x2 minus x1, right? I'm just going to call this one x1, y1, and I'm going to call this one x2, y2. It doesn't matter which one you call, all right? Whichever one you're most comfortable with, do. Okay? So I have 5 minus 6 over 4 minus negative 2. This is going to give me a negative 1 over 6, right? Now, remember, I want the perpendicular line, right? So what am I looking for? I want my this is perpendicular, right? So I want my negative reciprocal of the slope that I found there, right? So the negative reciprocal of negative 1 over 6 is going to be just positive 6. All right. And then I want it to pass through the 0.45. So you already know y equals mx plus b, right? So this is going to become y. Well, you know what? Let me just plug it. Yeah, let me do it step by step. This is going to be equal to 6x plus b. We're going to plug in the point that we were given, which is the 4, 5, right? Plugging it in, what do I have? I have 5 is equal to 6 times 4 plus b, right? 6 is 12, 24. So this becomes 5 is equal to 24 plus b. You're going to subtract the 24, which you do to one side, you do to the other. And we have negative 19 is equal to b, right? Now let's rewrite what we have. We're going to have y is equal to 6x minus 19. This is my formula. Questions on it? Everybody got it? Got it now? Awesome. Awesome. Good, good, good. All right. We good or y'all need to see another one? Good? All right. Let's talk about something interesting now. We're going to talk about solving a system of linear equations using a graph. So a system of linear equations includes two or more linear equations. The graphs of two lines will intersect at a single point if they are not parallel, right? Two parallel lines can also intersect if they are not coincident, right? Which means that they are the same line and they intersect at every point. For two lines that are not parallel, the single point of intersection will satisfy both equations and therefore represent the solution to the system. To find this point, when the equations are given as functions, we can solve for an input value so that f of x is equal to g of x, right? In other words, we can set the formulas for the lines equal to one another and solve for the input that satisfies the equation, right? Then after that, plug it back into one of the equations, you get the output, boom. That's the answer right there, all right? Let's take a look. This is going to be fun. Check this out. So finding a point of intersection algebraically, we have h of t is equal to 3t minus 4 and j of t is equal to 5t, excuse me, 5 minus t. Sorry about that, right? So I want to find the point of intersection, right? What I'm gonna do, this is kind of like, it's h of t, but it's kind of like y equals 3t minus 4, and it's kind of like y equals 5 minus t, right? Set them equal to one another. So this becomes what? 3t minus 4 is equal to 5 minus t. Let's solve for t, right? So what am I gonna do? I'm gonna add 4 over here where I do to one side, I gotta do to the other. I'm gonna add t over here where I do to one side, I gotta do to the other. So now what do I have? I have 4t is equal to 9. Divide by 4, what you do to one side, you do to the other. So now I have t is equal to 9 over 4, right? That's the input value, right? Take that input value, pick one of the two formulas up here. It doesn't matter which one. It could be the top one, could be the second one. It doesn't matter. Pick one, plug it in, right? And then solve for whatever's left over. I'm gonna pick the second one. So I have y, sorry. All right, I have y is equal to 5 minus t. T for me is what? 9 over 4, right? Put this as like over 1. So this becomes, let me see, I gotta multiply this by 4, multiply this by 4. This is what? 20 minus 9 over 4. Call that, what's that, like 11? Something like that. So this is like 11 over 4, right? The answer to this solution set is the point 9 over 4, comma 11 over 4. That's it. So it's two answers, right? 9 over 4. Well, not two answers, one answer, but the x coordinate is 9 over 4. The y coordinate is 11 over 4. And that's it. That's where they intersect that. All right. So basically, they're equal to y. Even though it's h of t and j of t, they're basically like y's, right? I'm setting both of them equal to one another so I can solve for their input. And then once I have the input, I just pick one of the formulas. It doesn't matter which one. And then I get out the output from there.
Well,
Uh-huh.
like, plug that, like, with the nine, with the X's, or
Mhm.
with the Y's.
Yeah. I could have done it in the first one. It just said it looked like that would have been more math, so that's why I was trying to avoid math. Um, just want to show you guys what this looks like graphically here. So this is it right here. These are the two lines, right? And you see where they intersect at? 9 over 4 and 11 over 4, right? That's the answer to the solution to the system of equations, right? Questions on this?
So if you get another over four with the answer you got, let's just plug it in the nine over four.
Exactly. Into one of the equations. Yeah. If I plug it into the other one, I'll still get out 9 over, I mean 11 over 4, you know? So it doesn't matter which one you do. Mhm. So if you were asked to find the point of intersection of two distinct parallel lines, should something in the solution process alert us to the fact that there are no solutions? So yes, after setting the two equations equal to one another, the result would be a contradiction. 0 equals a non-zero real number. All right. So basically, it'll jump out at you. Over here, we're looking at the figure. 1 second. Well, the same figure that we just looked at.
I don't think I'm
How would you know if you what?
giving you like, same thing, I was like,
Yeah.
outside of like, not just looking at the glass, I would just nothing, don't intersect.
Well, if they don't intersect, just looking at it rawly, the slopes would be the same slope, right? So like that's parallel slopes, you know?
Yeah.
Um, and even so, if you did it algebraically, it wouldn't work, you know? So like you wouldn't get a nice clean like x equals 9/4. You know, it'd be something like stupid, like 0 = 9/4, which makes no sense, you know? Yeah. So it would like really contradict itself. All right. So let's see. It says look at the graph and identify the following, right? Our x-intercepts, y-intercepts, slope, um, is J of t parallel, perpendicular, neither, same thing, and then increasing, decreasing, transformation, identity. Okay. So let's look at our y-intercepts, right? So what are the y-intercepts here? Let's do J of t. J of t is the orange one, by the way. All right. What is the y-intercept there? Where does it cross the y-axis at? At 5. Did you say that right? So boom. What about the h of t? What is that? H of t. What is the y-intercept there? Close. No. Go down a little bit further, not 3. What is it? -4. Okay. X-intercepts, a little bit harder now. So what's the x-intercept for J of t? J of t is the orange one, of course. 5. Very good. What is the x-intercept for H of t? That's the blue. 1 and change. I honestly can't tell, so I'm literally gonna write that. A little bit harder. What's the slope? Both. You can kind of cheat a little bit. You have the functions right here. That's H of t, that's J of t. So 3 and what else? Okay. So J of t, -1, H of t, +3. Okay. Let's see what else they're looking for. So J of t, that's the orange, right? Is that parallel or perpendicular to H of t? J of t, the orange one, right? Is it parallel to H of t or perpendicular to H of t? Which one? Say it again. Perpendicular? No. Yeah. Yeah.
The slope isolated.
Hmm.
Yes. That's driving itself to the
Right. So what would you say? Yes, no, neither. Which one? Parallel, perpendicular, or neither?
well, if the slope by itself was perpendicular, they will have to be the same, you know.
Negative reciprocals of one another. But they both got different slopes. So what is this? Parallel, perpendicular, or neither?
Neither.
Neither. All right. This is neither parallel or perpendicular. If they were perpendicular, they'd have the same slope. If they were, excuse me, if they were parallel, they'd have the same slope. If they were perpendicular, they would have the negative reciprocal of a slope. All right.
If they only, perpendicular when they have negative, right?
Exactly. Yeah, so they would have looked like a T crossing. I'm sorry? Okay. So if they're parallel, right, they'll have the same slope, the two equations. If they're perpendicular, though, one slope will be the negative reciprocal of the other. Right? In this case, they have two different slopes, so this is neither. Right? All right. J of T, the orange one, right? Is that increasing or decreasing from left to right, the same way you read a book? No,
No,
decreasing. The orange one, right?
Yeah.
From left to right, decreasing, right? F, excuse me. So it says write a transformation description of J of T from the identity toolbox, right? So first off, we know that this is going to be a negative reciprocal, right? So our toolbox, we have y is equal to x, right? So we want to flip this, right? So this is going to be y equals negative x. That's the first thing, right? Then we're shifting it over, right? How did we shift? It looks like left and up. We went up 5 and we went to the right 5, right? Because that's where our intercepts are, right? So that being said, if we're going to the right, that means we're subtracting 5, right? So far I got negative of x minus 5, and I went up 5 plus 5. And that equals the J of T. Right? 5 to the left, 5 up. That's it. Negative, of course, because it's on the other side, negative slope. All right. Questions, anybody?
If you just flip it from a decrease to increase, so they would just make it.
We're trying to get it from the original, like y equals x, just going straight through the origin to what it is right now. So we're trying to like do a transformation to it to get it to where it is right now. So we moved over 5 units to the right, which is minus 5, and then we moved 5 units up, which is plus 5. And that's it. I know it doesn't look like that from the picture, but that's what it is.
So,
Picture's just like really well drawn.
what the change, so,
Just the x minus 5 and the plus 5. That's it.
and that changes to what, the blue line or
No, the orange we're focusing on. Yeah,
it changes the orange one
to match what it is right now.
but what if that just be the equation we had at the time?
Supposed to be.
Well,
Yeah. And when we do this out, we get negative x plus 5, so negative x plus 10. I don't know. Up top, what happened? We had negative x, and then we just subtracted 5, so it shifted over to the right 5. You know? But still, our y-intercept is positive 5. You know? So that's what's kind of throwing it off. All right, let's move on. Let's look at a little story. All right, so curved antennas, right? Such as the ones that are shown right here, right? These look like they pick up everything, HBO, all of that, right? Curved antennas, such as the one shown, are commonly used to focus microwaves and radio waves to transmit television and telephone signals, as well as satellite and spacecraft communication. The cross section of the antenna is in the shape of a palabra, right? Which can be described as a quadratic function. In this section, we will investigate quadratic functions, which frequently model problems involving area and projectile motion. Working with quadratic functions can be less complex than working with higher degree functions, so they provide a good opportunity for a detailed study of function behavior, right? Promise you this is going to be real easy. So first, let's just talk about the characteristics of the palabra, and then we'll get into the nitty-gritty details, all right? So, so first things first, recognizing characteristics of parabolas, right? The graph of a quadratic function is a U-shaped curve called a parabola, right? One important feature of the graph is that it has an extreme point called a vertex, right? If the palabra opens up is like a cup, right? Then the vertex represents the lowest point on the graph or the minimum value of the quadratic function. If the palabra opens down, so it's like, I don't even know how to do that, but like that, I guess, right? Then opens down. Where did I leave? Yeah, the vertex represents the highest point of the graph or the maximum value. In either case, the vertex is the turning point of the graph. The graph is also symmetric about the vertical line drawn through the vertex called the axis of symmetry. Really important. All right, so here's what a basic parabola looks like, right? It's a U, as you can see in the blue. We have an axis of symmetry that goes down the middle that bisects it into two halves, right? It's symmetric. What's on the left is on the right, right? It has y-intercepts or one y-intercept. It has two x-intercepts sometimes, right? The vertex is a point, right? Not the line itself. The line is called axis of symmetry. The vertex is a point, but the x coordinate of the vertex, right, is the axis of symmetry. The x coordinate, yeah. So that would be one, no? Yeah, one.
Oh,
Yeah, because you see one, that, yeah.
well, there's twist.
Those are the x-intercepts. That's different. Yeah, that's different. So the vertex is like the highest or the lowest point, right? So yeah, that's a palabra. Really interesting. So the y-intercept is the point at which the palabra crosses the y-axis. The x-intercepts are the points at which the palabra crosses the x-axis. If they exist, the x-intercepts represent the zeros or roots of the quadratic function, the values of x at which y is equal to 0. Okay? So the x-intercepts are the answers to the quadratic equation, basically. So for example, in this situation right here, right? This example, we want to determine the vertex, the axis of symmetry, the zeros, x-intercepts, and the y-intercept, right? So we can kind of tell what the vertex is, right? The vertex would be this point right here at the very bottom. That point is what? 3, comma 1, right? So our vertex is 3 comma 1, right? We'll just put this 3 comma 1. We have no x-intercepts. There is an answer for this. You can get this by completing the square or by what's that other thing? The quadratic formula, right? To get what the x-intercepts would be. They would be imaginary because it's lifted up like that, right? My axis of symmetry, can't spell that. My axis of symmetry, right, is the x coordinate, right, of the vertex, right? So you see how the vertex is 3 comma 1. My axis of symmetry here is just x equals 3, right? That's that vertical line that goes through. Y-intercept right here, right? So this looks like what? 0 comma 7, right? So that's my y-intercept. 0 comma 7. And that's it, right? I kind of need the equation to get the x-intercepts, you know? Let's see this. Understanding how the graphs of parabolas are related to their quadratic functions. So the general form of a quadratic function represents the function in the form ax squared plus bx plus c, right? Where a, b, and c are real numbers and a cannot equal 0, right? These are the coefficients, the numbers that are in front. If a is greater than 0, the parabola opens upward, right? Upward, right? If a is less than 0, the parabola opens downward. So downward like this, right? We can use the general form of a parabola to find the equation for the axis of symmetry. So here goes the equation for the axis of symmetry right here. Again, this is not your formula sheet, but I'm just letting y'all know, right? So the axis of symmetry is defined as x is equal to negative b over 2a, right? We use the quadratic formula on your formula sheet as well, right? X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a to solve ax squared plus bx plus c is equal to 0. For the x-intercepts or the zeros, we find the value of x halfway between them, which is x equals negative b over 2a, the equation for the axis of symmetry. All right? I know, nothing new. Y'all seen this before. Just running through. All right. So this figure right here represents the graph of the quadratic function written in general form as y equals x squared plus 4x plus 3. In this form, our a, which is the number that's in front of x squared, is 1. Our b is 4, which is the number that's in front of x. And our c is 3, the number that's by itself. Because a is greater than 0, the parabola opens up upwards, right? The axis of symmetry is x is equal to, again, negative b over 2a. In our case, we have negative 4 over 2 times 1, which gives us a negative 2, right? This also makes sense because we can see from the graph that the vertical line is x equals negative 2, right? So that's our axis of symmetry, which divides the graph in half. The vertex always occurs along the axis of symmetry, all right? For a parabola that opens upward, the vertex occurs at the lowest point on the graph. If it was a negative parabola, it would have been the highest point, right? So in this instance, we have negative 2 comma negative 1, the x-intercepts. Those points where the parabola crosses the x-axis occur at negative 3 comma 0 and negative 1 comma 0, right? Those are the x-intercepts, the answers to the question, basically, right? That's it. So let's talk about another form that this could come in. It's something that we need to know real quick. It has its advantages and its disadvantages. So the standard form of the quadratic function, right? Presents the function in the form f of x is equal to a times x minus h squared plus k, where h comma k is the vertex. Because the vertex appears in the standard form of the quadratic function, this form is also known as the vertex form of a quadratic function, right? So H would be your axis of symmetry, K would be you put them together, you get the vertex, right? As with the general form, if A is greater than 0, the parabola opens upwards and the vertex is the minimum. If A is less than 0, the parabola opens downward and the vertex is the maximum, right? So this next figure represents the graph of the quadratic function written in standard form as y equals -3 times x plus 2 squared plus 4, right? So since x minus h is equal to x plus 2 in this example, h is equal to -2, right? That's our axis symmetry. And a is equal to -3, h is equal to -2, and k is equal to 4. All right? So the parabola opens downward. The vertex is at -2, comma 4. Let me get that for you. Bear with me 1 second. This graph is ridiculous. All right. So here we go. So you see we have our vertex at the very top, right? Vertex at the very top, that's going to be our h. H is -2 from our general form here, right? Our vertex form. Our k is going to be 4, right? So there we go. That's the +4 for the vertex. All right. We have our x-intercepts. No, those aren't x-intercepts. But we can find those. Long story short, we can find those. You set it equal to 0 and you solve for it. Then we can get that, right? That's it. All right, the standard form is used for determining how the graph is transformed from the graph of y is equal to x squared, right? So this figure shows that this is the basic function right here. This is one of our toolkit functions, y equals x squared, right? Basic. Too much. Sorry about that. 1 second. So if k is greater than 0, the graph opens upward, whereas if k is less than 0, the graph shifts downward, right? That's adding all that, right? So if the figure 5 for as k has k greater than 0, so the graph shifted 4 units upward, right? So wrong one. So you see how we're 4 units upward? That's adding the k right there. Blah, blah, blah. Right. So if h is greater than 0, the graph shifts towards the right. And if h is less than 0, the graph shifts towards the left. Right. So in the figure, we can see that h is less than 0. So the graph is shifted 2 units to the left. Right. So over here, instead of being in the center, we're 2 units to the left. Right. The magnitude of A indicates the stretch of the graph. So if the absolute value of A is greater than 1, the point associated with a particular x value shifts further from the x-axis so that the graph appears to become narrower, right? And there is a vertical stretch, but if the absolute value of a is less than zero, is less than one, excuse me, the point associated with the particular x value shifts closer to the x-axis, so the graph will appear to be wider, right? Wider. But in fact, there's a vertical compression, right? So if the figure, right, where the absolute value of a is greater than one, so the graph becomes narrower. The standard form of the general form, right, are equivalent methods of describing the same function. We can see that by expanding out the general form and setting it equal to the standard form, right? Boom, boom. So we have a times x minus h squared plus k is equal to a x squared plus bx plus c, right? And then all we do is just expand it, left and right. For the linear terms to be equal, the coefficients must be equal, right? So we eventually end up with negative 2 AH is equal to B. So H is equal to negative B over 2A. Our axis of symmetry formula, that's how we get it, right? This is the axis symmetry we defined earlier. Setting the constant terms equal, we get a times h squared plus k is equal to c. And then we have k is equal to c minus a h squared. Then we have c minus a times b, negative b over 2a squared, where we get, and which we end up with c is equal to, a h squared plus k, excuse me, is equal to c minus b squared over 4a. In practice, though, this is usually easier to remember that k is the output value of the function when the input is h. So f of h is equal to k. All right. Don't need to memorize this, just going through the motions with you with this one. All right. But here's what you do need to know. Give you a little definition real quick. So this is the forms of the quadratic function. A quadratic function is a function of degree 2. The graph of quadratic functions is a palabra. The general form of the quadratic function is f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. The standard form of the quadratic function is f of x is equal to a times x minus a squared plus k. The vertex, right, h comma k is located at h is equal to negative b over 2a, right, and k is equal to f of h, which is equal to f of negative b over 2a. Long story short, you find your axis of symmetry. When you find it, you plug it into the formula. It gives you back the vertex. That's it. All right. Sounds a little complicated, but it's not that bad. Let me give y'all a little instructions, little how-to right here. Go. This should be good. So given a graph of a quadratic function, it says write the equation of the function in general form. So identify the horizontal shifts of the palabra. This value is h, right? Identify the vertical shifts of the palabra. This value is k, all right? Substitute the values of the horizontal and vertical shifts for h and k in the function f of x is equal to a times x minus h squared plus k. Substitute those values of any points other than the vertex on the graph of the palabra. For x and f of x, solve for the stretching factor, which is the absolute value of a. If the palabra opens up, a is greater than 0. If the palabra opens down, a is less than 0, which means that the graph was reflected about the x-axis. Expand and simplify to write in the general form. That's it. All right. I got you. You're gonna see this in the homework where they're gonna ask you, like, give me the general form of something.
That's just like 28, wasn't it? Where you had
It was. Yeah.
the.
Mm-hmm. Yeah, we mentioned it, but we're going a little bit more in depth right now.
Go back to the negative b over 2a
Mm-hmm.
squared thing.
All right, so in this question, they're asking us to write an equation of the quadratic function g, right, as a transformation of f of x equals x squared, and then expand the formula and simplify in terms to write the equation in general form, right? So let's make some observations here, right? I have my vertex right here. That's my vertex. That point is what? -2, comma, -3, right? So I could tell you right off the bat, I have y is equal to a, hold on. Why is it not writing? One second. Okay, there we go. A times x minus h. H in this case is going to be +2 squared, right? And then -3. So it's like we got shifted to the left 2 units and then down 3 units, right? And then whatever the magnitude of A is, right? Does that make sense? Hmm. Yeah.
Oh,
So if it had moved up, it would have been like plus K. Yeah. Right. Mm-hmm. That's it. So to figure out A, here's what we're gonna do, right? We're gonna take one of the points, come back, one of the points that we have on the graph, and we're just gonna plug it in, right? So looking for a nice point here. Doo, 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 doo. I mean, we could take the vertex, but no, that feels like cheating. This point right here, this is a nice point right here. So I'm looking on the graph to see where I get like a nice X and Y, you know? So this is like 0, comma, -1, right? If I plug that into the formula that I just found, I can get out A. That's what I want to do. So my Y here is -1 is equal to A times my X is 0 plus 2 squared minus 3. Let's do the math on this. -1 is equal to A. 2 squared is what? 4. So I'm going to say times 4 minus 3. Let's add 3 over here, or we do to one side, we do to the other. So I have what? 2 is equal to 4A. Let's divide by 4, divide by 4. So I have A is equal to 1/2, right? Rewrite this, my final answer, Y is equal to 1/2 X plus 2 squared minus 3. And that's the equation for this parabola, right? Questions on this? Right? So I found the vertex, H and K. I plug that into the standard form, right? Which is A times X minus H squared, right? Plus K. Boom, right? That was the easy part. Then after that, I found a point on the graph. That was the hard part. And then I took that point, plugged it in for X and Y to solve for A. Now that I have A, I have the full equation right there, right? If I wanted, I could even go a step further. I could expand this vertex form and put it into ax squared plus bx plus c form if I wanted to. All right. So that's how we do that. Skip that. It was something that we need to know. Little t. So given a quadratic function in general form, ax squared plus bx plus c equals 0, right? We want to find the vertex of a parabola, right? So how do you find the vertex from like the general um quadratic equation, right? So you want to identify first what is A, what is B, what is C, the coefficients. Then you want to find H, right? Remember, H is going to be negative B over 2A. When you find that answer for H, you plug it into the regular equation that you have, right? The AX squared plus BX plus C. And then the answer that you get back out from that, that's K. Put them together, you have the vertex, right? And that's how you find the vertex from a standard form. All right. For example, yeah, go ahead. For example, right? Finding the vertex of a quadratic function. I have f of x is equal to 2x squared minus 6x plus 7. I want to rewrite the quadratic in standard form, the vertex form, right? So first thing is first, I got to find the vertex. So the vertex is h is equal to negative b over 2a, right? And I know that a here is equal to 2, b is equal to negative 6, c is equal to 7, right? Just plug them in. So this is going to be negative of negative 6 over 2 times 2. Call that 6 over 4. This is going to be what? 3 over 2, right? That's my axis of symmetry. That's my h, right? Plug that into the original formula. I want f of 3 over 2. This is going to give me 2 times 3 over 2 squared minus 6 times 3 over 2 plus 7. Let's just do a little math real quick. This is going to be what? 2 over 1 times 9 over 4 minus 6 over 1 times 3 over 2 plus 7. Let's just say 7 over 1. Multiply these out. That's 1. That's 2. I got 9 over 2 minus this is 1. This is 3, right? So 3 times 3, this is 9 over 1 plus 7 over 1, right? Now, you know, in order for me to put these together, I gotta just have the same denominator. Multiply this by 2. What I do to the bottom, do to the top. Multiply this by 2. I do to the bottom, do to the top. So what do I have? I have 9 minus 18 plus 14, all divided by 2, right? Let's put these together. What's that, like 19, 23? So 23 minus 18, what's that, like 5? 5 over 2, right? This is my K, right? Right into the standard form, right? So I have y is equal to a times x minus my h. I forgot what h was. H is 3 over 2 squared plus my k, which is the 5 over 2. Now, this is a little bit easier. I already know what a is. A was given up top is 2. Just call it a day. Y equals 2 times x minus 3 over 2 squared plus 5 over 2. And that's it. I was a little fast. Everybody understand? But you can watch it again. See. All right. So long story short, find the axis of symmetry, plug it into the formula, find the vertex, go right into the standard form. At that point, you know what H is, you know what K is. Boom, boom, plug them in, right? And then after that, right, you try and solve for A, right? When you have the standard form, you already have A, so you kind of could just chill, you know? But if you didn't have A, you find a point, you can plug in any number you want in there, find a point, plug it in, solve for A, right? Even 0, right? We could have plugged in 0 in the standard form and got the y-intercept and just used that to solve A. That's legal too, right? Right? So, special note, one reason we may want to identify the vertex of the parabola is that this point will inform us where the maximum or minimum value of the output occurs, K, and where it occurs, X. Right? So let me talk about domain and range real quick for the quadratic formula. All right, or quadratic function, excuse me. All right. So finding the domain and range of the quadratic function, any number can be the input value of a quadratic function. Therefore, the domain of any quadratic function is all real numbers. Remember that. Domain for a quadratic function is all real numbers. Because the parabola, this is where it gets tricky. Because the parabolas have a maximum or a minimum point, the range is restricted, right? So since the vertex of a parabola will either be a maximum or minimum, the range will consist of all y values greater than or equal to the y coordinate at the turning point, or less than or equal to the y coordinate at the turning point, depending on whether the parabola opens up or down. So if the parabola opens up like this, right, my range will be from the vertex at the bottom to infinity, right? If the parabola opens downward, right, my vertex is at the top, right? That means that my range, right, is going to be from wherever the vertex is to negative infinity. Well, I should be negative infinity up to the vertex, but you get the idea. All right. So that's what that means. So real quick, give you a little T. So a little how to. So given a quadratic function, find the domain and the range. Step one, identify the domain of any quadratic function as all real numbers. Step two, determine whether a positive or negative, right? If A is positive, the parabola has a minimum. If A is negative, the parabola has a maximum. Step three, determine the maximum or minimum value of the parabola, K, right? And step four, if the parabola has a minimum, the range is going to be by f of x is greater than or equal to K, or from K again is the vertex, the y coordinate, right? All the way to infinity. If the parabola has a maximum, right? Maximum at the top, right? The range is given by f of x is going to be less than or equal to K, or from negative infinity up to K, right? Two. Let's talk about one more thing, and we could call it at that. So this is finding the x and y intercepts of a quadratic function, right? Much as we did in the application problems, right? We also need to find intercepts of quadratic equations for graphing parabolas. Recall that we find the y-intercept of a quadratic by evaluating the function at the input of 0. And we find the x-intercepts at locations where the output is 0, right? So if you have a parabola that's raised, like this first one right here, right? This has no x-intercepts, right? Imaginary numbers, right? If you have a parabola that's sitting on the x-axis, like here, you have one x-intercept. And then, of course, most parabolas will look like this, where across the x-axis and you have two x-intercepts, right? That's like two roots, two answers to the equation right there. All right. So real quick. So given a quadratic function, f of x, right? We want to find the y and the x-intercepts, right? Step one, evaluate what f of 0 is to find the y-intercepts. That means you plug in 0 for x, and whatever number is left over, that's your y-intercept, right? Step two, solve the quadratic equation, f of x equal to 0 to find the x-intercepts. Now you have many techniques to do this, right? You can complete the square, you can do the quadratic formula to find those x-intercepts, whatever works best for you, all right? Again, on your formula sheet, don't need to memorize it, right? Da, da, da. And I think we're good with this. Just spoke about that. Yeah, I think we're good. We could call it at that. Questions on this, anybody? It's kind of the same thing that we did in 28, right? Finding the vertex. Well, we never spoke about vertex in 28, right? So that's the new thing. But overall, you'll see it in the homework. All we're looking for is the vertex, axis symmetry, x-intercepts. We already know how to do that, right? From 28, right? We're just solving for the roots. Use quadratic formula, use completing the square. If you have a graph, you're just looking at where it's crossing the x-axis and you're done, right? Y-intercept, very simple. Plug in 0 for x. Whatever number's left over, that's your y-intercept. That's it, right? We might have some application questions for homework, right? Where it could be like, let's say you're throwing a ball and it creates a parabola. They might ask you like, oh, what's the highest point, right? What does that mean? I'm not asking you what is the vertex, right? What is the K for the vertex, right? I might say like, all right, I threw the ball and then it hit the floor over there, right? So at what point, let's say if it was time, for example, right? How much time did it take for me to throw the ball from here and it hit the floor over there? What am I asking you for? I'm asking you for an x-intercept, right? Quadratic formula, boom, right? Um, if you're doing an application question, sometimes it doesn't make sense to have a negative answer. You know how sometimes the parabola will have like one intercept will be negative and one intercept will be positive, right? So if I threw the ball over there, it doesn't make sense that the time that it would take to go over there is negative. Negative time doesn't really make sense, so it would be positive. So if you get two answers, you are going to get two answers. But when you look at the two answers that you're going to get, the positive answer, that would be the one to solve the application. All right. So that's like the projectile. All right. Works the same way with bullets. You know, I don't know if you guys remember seeing this in Suicide Squad, right? When Will Smith was talking with his daughter in the movie, right? He was talking about like how to aim the gun and shoot it. Yeah, it's the same thing. Mhm. So so test on Thursday. We down for that?
See, add this.
This will be on it. Yeah. But nothing from tomorrow, nothing from Wednesday, nothing from Thursday will be on the test. Yeah, this is the last topic. Yeah. I owe you guys a homework. I didn't finish posting this homework, but I will finish posting it. Just get it done. Like I didn't feel good about giving you the test tomorrow because I'm like I'm giving y'all new homework. You guys didn't even have a chance to go to tutoring or ask any questions about it. So that's why I wanted to do it on Wednesday. But a lot of people said they rather Thursday, so I'm down for that too.
But if we do it Monday, want to do this part? Or
No, you would.
So,
Yeah, yeah, yeah.
for example, for tomorrow on, we made in the account.
You say it again tomorrow.
Tomorrow class and Wednesday class
Yeah, that's not on the exam.
is not so bad.
It's not there.
Thursday or Wednesday?
Thursday. Yeah.
Thursday.
Yeah.
So,
Like there'll be new material on Wednesday excuse me, on Tuesday and Wednesday, but that's gonna be like for next week.
Oh,
Well, that's it.
So last week and today. And today. Then that's it.
Trying to figure out what I did when I don't know what I
Oh,
did.
got you. I'm gonna do that real quick. Hold on, let me just stop this real quick. Stop. Nah, I'm done with attendance. Yeah.